here. Okay, so module 3 is a set theory. So in set theory, so we have to understand the meaning of the set. Okay, the meaning of the set is we want to organize. Okay, so something like your all clothing, your socks, your shoes are all over the place, and you want to organize. Well, we organize. Your shoes has to be paired and put that into the shoe rack, and the clothings, and you have to put socks in the socks drawer. You have to put in the drawers. Okay, so make it clean. Or you have so many papers, you put that into the paper into the folder. So in math, we want to collect all this math element and organize. That's what we call the set. You can think as a set as a box. If you get confused, set as a box. So here is a one box. You organize all these math elements in one box. Here's another box. You organize all these elements in another box. Do you understand this? So we want to understand the meaning of a set. So as you see in the box, the set is a collection of object, okay, whose element is clearly determined. That object is called element. So there are two words here. One is a set, the other is element. So let's understand the meaning of these two. Okay, so the meaning of set, okay, the meaning of a set is like a box. So we want to organize, okay, organize the stuff. And an element is the members of a given set. So if I want to have all these socks into the box, those socks are elements, okay? If I want to put those the books into the box, those books are element. Do you understand this? So those element has to be clearly determined. This part, you might be wondering why we want to write it. The element is clearly determined. The socks is clear. I know this is a socks. I know this is a sweater. Sweater cannot go into the box of socks. So we know it's clear. Here's a shoes. The shoes has to be a shoe box, not in the socks. You know what I mean? So there are some parts it's not clearly determined. So let me give you an example. I want to collect favorite movies of all times. I want to collect favorite movies of all times. Make a box, make a set. Okay. So let me see. I can put Batman Return. Okay. I can put Beauty and the Beast. And then you might think, oh no, Beauty and Beast, that's not my list. I want to take it out. So if it is a person's opinion, cannot be clearly determined. For me, it is my favorite movie, but for you, it's not your favorite movie. You know what I mean? So personal opinion cannot be clearly determined. So clearly determined means everybody agreed. So if I said, I want to find a set as even numbers. So we all agree what are even numbers. So 2, 4, 6, 8, 10, so on and so forth into that box. We know 1, 3, 5 cannot get into the box. You know what I mean? So clearly determined. All right. So those are elements. So all these clearly determined elements in the box we called well-defined. So well-defined is the redundant of the meaning of clearly determined. So any question of these three meanings here, set, element, well-defined. So once we have that, then we want to know how to define a set. So how do we write a set? So write a set, the easiest thing we can write a set, we write in words, okay? So we write in a sentence. Okay, set is blah, blah, blah. Okay, so this is the set of a box of socks, okay, something like that. Or we write it in mathematical notation. So this is the important part that I want to go over this, okay. So the first we describe in words, okay. So we understand how we describe in words. So here is words description. The next one, this part is extremely important, roster method. So we are going to use again and again in roster method. To highlight it, roster method right here. Roster method, it is writing into mathematical notation. So this is the first time we see math. So we write it a set, okay, any type of set equal to, okay, And then we open braces and end braces. So this is a mathematical notation, okay? And then we list everybody, list all the elements here. List all the elements here. If I said set is even numbers, I said 2, 4, and so on and so forth. Everybody write it in here. You know what I mean? So roster method, list everybody, okay? We're going to practice in a minute. And the last one, it is a set theory, okay? Set builder notation, set builder notation. That is, we're writing more compact notation right here, more compact notation. So it still use set notation, but here is a, okay, here is a, the bar here. Okay, here is a bar here. So this bar means if, okay, bar means if. So instead of listing out everybody, so for example, if I want to write it out all even numbers, okay, all even numbers, then when can I stop? There are infinite many numbers. I cannot stop, but I can just say X satisfied even numbers, so it makes it easy, okay? So we give representations here. Okay, here's a one question. So if I said, okay, so set of all even numbers, there are 2, 4, 6, 8, 10, blah, blah, blah. Does it necessary to be order? In order. So meaning 2, 4, 6, 8, 10, that's usually we write it in order. But what if I mix, you know, take the orders like 2 and then 6 and then 4 and then 8, you know what I mean? In a set theory, order does not matter. We don't care the order, as long as you are listing all elements. Italy, is that okay with you? Okay, order does not matter, but we usually write in. Okay. It is because we get confused. So what if we don't write it in order? We get confused ourselves. So we usually write in order, but order is not required. Okay, any question? Let's have an example. Okay, let's have an example. So let's have one example. Okay, so example 1, represent the set of days of the week. Okay, days of the week. Use roster method and set builder notation. So first, we write this in a words. Okay, so word description. This is the word description. The element of set are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Those are the set. So in words, we write it. A set is a set of Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. It's the days of the week. This is the description of the set. And these are the element, okay, ELTS, elements. These are the elements. Roster method. W is, okay, so equal means is. Okay, equal means is. This is a mathematical wording here. Multiply of, okay, you have multiply of. 10% of, remember, of means multiply. Equal means is. W is, okay, the notation, open braces, close braces. So we start the set, we end it with the set. So this is a set of, that's how we read, okay, a set of. W is a set of Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, close braces. That's it. So it's like open a box. Okay, so here is open box. Here's a closed box. W is a set of open box, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and then close the box. That's the set. Okay, so you can think as a set as a box. Okay, W, it's the days of the week. I take the letter W. Okay, here's a one thing, I forgot to mention it. Set usually denoted by capital letter. Element usually denoted by small letter. Are we okay with this? Okay, so W, I take that as the week, as a W, is a set of, okay, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So roster method, you're listing all the elements. You're listing everybody. That's roster method. Are we okay with that? Let's look at set builder notation. So in set builder notation, we understand meaning of these 7 guys, meaning they are a day of the week. So I pick X. X represent Monday, X represent Tuesday, X represent Wednesday, Thursday, Friday, Saturday, and Sunday. So X represent everybody. So X is a day of the week. Are we okay with this? So W is a set of Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. W is a set of X if X is a day of the week. So there are same sets. So this is the same as that. So let me mark this. This is same as that. This is the same as that. So suppose we have a set. Make sure you know how to write it in word description. If it's describing words, make sure you know how to write it in roster method. Roster method equivalent to say set builder notation. And then we have a word description. So we can write it one to another. So make sure you know one set to another set. Let's have an example. So the bottom of the page, okay, example 2. How do we write in word description? Example 2 and example 3. Let's try these 2 examples here. Example 2, write in word description of the set. So P, capital P, is the set of Obama, Bush, Clinton, Reagan, and Carter. Okay. How do we describe this in words? Connor, so how do we describe this in words?
You put them in the set elements, right?
Yeah, this is the roster method. Agree? This is the roster method. This is the roster method that we wrote. Okay. Meaning we put out every element. Okay. How do we write? How do we describe this in words? So what kind of set is this? That's the question. What kind of set is this? Aaron, what kind of set is this?
I don't really know. I'm not really understanding this yet.
Okay, set here. Leslie, any idea?
Roster method.
This is a roster method. This is roster method, but we
So
want to describe it.
is it P is the set of Obama, Bush, Clinton, Reagan, and Carter?
Yeah, so what kind of set is this? Who are those?
Those are the elements.
Those are
right?
the elements, okay? But what kind of elements is there any common on Obama, Bush, Clinton?
The ex-presidents.
They are presidents. Okay, so we are writing P is a set of US presidents.
Oh, so you have to literally write out what it is.
You don't need to write it out what it is. Word description, write it in words.
Okay.
That's what it means, okay? Are we okay with this? P is a set of US presidents. Okay. So word description, we describe in words. Okay, roster method, we write that into elements, okay? All right, let's look at the third one. Are we okay with this? It's still confusing? All right, let's look at this. Next one. All right. Example 3, the bottom of page 74. Express set using roster method. Okay, now here we are writing in word description. So it's described in words right here. A set C is the set of US coins with a value of less than $1. Express set by roster method. Now you have a roster method. So I want to list it out all the elements of the set. So remember, this is the description, word description here. We describe in words. Set C is the set of all US coins valued less than $1. Are we able to listing out all the elements? Okay, Michael.
Yes. I'll
Okay.
get it.
Can you answer this? Can you write that into roster method?
Yep, I did W is equal to bracket, and then I did 1 cent, 10 cents, 25 cents, 50 cents, and 75 cents. Then I closed the bracket.
10 cents, 25 cents, 50 cents. Okay, $half. Close bracket. Okay. Are we okay with this? So you just list it out. That's what the roster method is. Roster method means you're listing out all the elements. Okay, you're listing out all the elements. So now my next question is the element clear? So do you understand why it is 1 cent? Do you understand why it's a 5 cent? Do you understand why I'm listing out all these elements? Yeah, it's clearly determined. Okay, I know I cannot put the any other coins like a Canada coin, Canada penny cannot get into here. You know what I mean? So clearly determined. It's everybody agree. Those are the US coins. Okay, no question. All right, I want you to turn the next page, page 75. It has a few examples here. So I want you to look at 43 and 44 right now. And let's do it together. Okay, 43 and 44. So make sure you understand how do you describe in words, write that into the roster. Then once you have a roster, know how to write it in the set builder. Once you have a set builder, know how to write it in the roster and back and forth, okay? Make sure you understand. Roster means listed out all the elements, okay? Word description, we describe in word. What are the sets? Okay, few minutes. Go ahead, 43 and 44. More exercise, you could understand better. Okay, so let me see. Are we able to do problem 43? Let's do it together. A set is a set of month begin with the letter A. Express this into roster method. Express this into roster method. Dorothy, what's that? A equal to?
I said A equal to April and August.
Excellent. April and August. Okay, that's it, right? So roster method, we listed out the elements. So there are April and August. Very good. Let's look at number 44. Again, we want to write in roster method. Now this time, it is given as a set builder notation. So M is the set of X such that X is a month that begins with the letter M, okay, letter M. So this is the set builder notation. All right, so X represent all the month, letter begin with M. Can we write this into roster method? Another way to say M equal to, we listed out all the elements, M equal to. Olivia, what's M equal to?
I said M equal to March and May.
March and May. Excellent. Okay, so that's how we write it. So any question of word description, roster method, and the set builder notation? We slowly get into the idea of doing this. Okay, roster method, we listed out all the elements. Set builder notation, we represent one element. Okay, and the word description, we write in Word. So I want you to continue. Do problem 45. Okay, it has 3 parts. Go ahead and try. That is the bottom of the page 75. Continue. Okay, so go ahead and do 45 and let's do it together. Few minutes. Okay, so let's do it together for the part 1. We want to write that into roster method. So all it's roster method, okay? The set of 4 seasons in a year, 4 seasons in a year. Okay, set of 4 seasons in a year. Jason, what do you think?
I did E, F, G, H, I. Oh no, wait, that's the seasons. I'm sorry. I thought that was the other one. No, I did spring, summer, fall, winter.
Okay, so spring, summer, fall, and winter. We have 4 seasons. This is the set, so we write the set notation. This is the season of the year, so let's say S as the seasons of the year. Okay. We all agree with this? Okay, let's look at number 2. A set X such that X is a letter of alphabet followed D comes before J. Okay, Kate? Kayla?
That follows.
Kate, are you speaking? Okay.
I'm not sure, to be honest.
Okay, so let's see. Kayla, you want to try?
Yeah, I put every letter between D and J, so I have E, F, G, H, I.
H and I, so Jason accidentally did. This is a set begin with the E, end with I. So followed by D, so E, F, G, H, and then before J, which is I. Write it out. And this is alphabet letter. I said A equal to like this. All right. Roster method. We listed out all the elements. All right, last one. The set of even natural numbers. So here is a word, you probably don't get this word, natural numbers. Okay, so let's understand the meaning of this natural numbers. Natural numbers, okay, so write it out. Natural numbers is the same as counting numbers. Okay, natural numbers is same as counting numbers. So there are many different characters in the number system. We have rational numbers, we have irrational numbers, we have integer, we have real numbers, and you know there are so many of those numbers. And the very beginning we study natural numbers, or it's called counting numbers. So that's the kindergarten or first grade you learned. Okay, what are those numbers? Those numbers are count by your finger. That's what counting number. So when you first count, you count 1, 2, 3, 4, whether you fold it or you put your finger around, like counting numbers. Counting number begin with the 1. It's because 1 is the first number you begin with. So 1, 2, 3, 4, and so on and so forth. Okay, those are the natural numbers, counting numbers. When can we stop? We can't stop. It goes forever. You know what I mean? So the set, write it here, set notation. If you cannot go really too far, I want to say, oh, I cannot go, but I know it goes forever. Do you want to write it thousands of those numbers and millions of those numbers forever? So we use 1, 2, 3 dots, and then we close that. You understand this? We use 1, 2, 3 dots, and then we close it. It's because we know it's in the same pattern, but we cannot write it out all these millions of those numbers. You know what I mean? All those millions of those numbers, but you know it's there. These 3 dots, it's called ellipses. Okay, ellipses. So ellipses are 3 dots. It's in the pattern of that, the number pattern, or in the element pattern. But we cannot write it out, but we know it's there. Another way to say it's because we use this ellipsis, we know 100 is here. We know 1,000 is here. We know 1 million is there. We know 99 is here. You know what I mean? So ellipsis skip this, but it's in here, okay? It's in the pattern. So natural numbers, I write it as n. Okay, here's a notation. So if I just write it at n, it could be like any letter, like S, A, M, N. So natural number has a special notation. I use natural number with the 2 bars of n, like this. So if you see notation with the 2n, like this bar, that is a set of natural numbers. Sometimes I denote n with the extra bar like that. So as you see, anytime you see those extra bars, that means a set of natural numbers. Do we understand this? Notation. Okay, notation. So even natural numbers less than 10, 2, 4, 6, 8, 10, and then begin and then end set notation. So even natural numbers, write it out this way. Is this okay? We agree with this, Connor?
I actually did 2 and 4 because I thought it couldn't equal to 10.
It's less than 10. Even natural
Yeah.
numbers less than 10.
So
Less than
okay.
10. So less than 10. So I don't include 10, less than 10. So even numbers less than 10. You can think as that way. Okay. We usually skip this like this. We usually say even numbers instead of even natural numbers. That's what it means, even numbers. So you guys know what's even numbers and odd numbers, right? We do. All right, even numbers, 2, 4, 6, 8, 10, and so on. So any number can be divisible by 2, even numbers. All right, so here's one question. Suppose you have a set. Suppose you have a set. I have a set. There's nothing inside. Can this be a set? So we have a set right here. It has elements. We have a set has element. We have a set as element. So the set has the elements. Set has elements, right? But what if we have a nothing inside? There is nothing in here. But I open the braces, I end the braces, so there is nothing inside. Is this can be a set? Is this a set? It's like set is a box. Remember that? Set is a box. So you have a box filled with the elements. Now you have a box, there's nothing inside. What kind of box we have? It's an empty box, right? And we have empty box, empty set. So this is what we call the empty set. Do you understand this? This is what we call the empty set. So let's turn the next page. Okay, let's turn the next page. Let's understand empty set. Okay, so empty set is the set contains no elements. Contains no elements. Empty set. So it's like empty box, empty set. So this is empty set. There's nothing in here. Another notation, nothing means this. Nothing means this. Do you understand this? Nothing means this. Okay, they are equal. Empty set. Notation, empty set, empty set. Do you understand this? Empty set and empty set. Now here's a question. Suppose I have an empty set, okay, and then you are writing in fancy notation. I write it that. Is this empty set? So I have a box that's set, right? And this is another box. I have an empty box sitting inside of a box. Is this empty set?
No, because there's something in it.
Yeah, it has a set, it has a box inside of a box. So it has element. So this is not empty set, okay? Not empty set. So empty set has to be empty. It's like a Russian doll. So you have a doll and then there's a doll inside and then doll inside. You know what I mean? So here's a box, there is a box inside. So some of us try to write it into fancy notation during the exam, write it set and then, okay, I have extra time. I want to write it like that. That's not the empty set. You know what I mean? So just leave it alone. This is empty set or this is empty set. That's okay, but you cannot combine together. You know what I mean? Okay, so empty set has one element, empty set. Okay, so you can't have this. All right, now the next thing is, I want to know which one is empty set. So problem 46 on page 76. Okay, on page 76. Okay, so right here, problem 46, I'll make it bigger. Okay. Which one is an empty set? So it has a 1, 2, 3, 4. So 1, 2, 3, 4. Which one is an empty set? Okay, quick looking. Which one is empty set? Another way to say, are you able to find element of the set? If there is an element, not an empty set. There's no element. Yes, it is empty set. Okay, so look at the set on which one is an empty set.
4.
4 is an empty set. So that's clear. This is an empty set. How about 3? Is it empty set? No, this is not empty set, right? That's not empty set. Anything? 1 and 2 looks similar. So 1 and 2 looks similar. Go ahead and check 1 and 2. What's the difference between the case 1 and 2? One is or, the other is and. Okay, one is or, the other is and. So in set theory, extremely important, you have to understand the meaning of or and meaning of and. Okay, so if you understand the meaning of or and and, you got 50% done. That's how important or and and. So let me explain you meaning of or. Or means one or another. You understand this? Or means one or another. Okay, or means one or another. So roughly we said everybody. Okay, one or another. And means we're looking at in common. Okay, so one and another, meaning and means, okay, common. All right, so let's look at it. Number one, a set X is a set of the X is a number less than 3 or greater than 5. Okay, one or another, less than 3 or greater than 5. What are those numbers? A number less than 3 or greater than 5. Can you find a number? Less than 3 or greater than 5. Can you find a number? Let's see. Iterate. What do you think? Can you find a number which is less than 3 or greater than 5?
I said between 2 and 4.
Okay, so you have a 2 here. Okay. Greater than 5. I want to say less than 3. Here's a 2. Greater than 5. I have a 7. So another way to say there are a lot of numbers. Okay, there are a lot of numbers, and you can find some elements in here. 7 is greater than 5. 2 is less than 3. One or another. So this is not empty set.
Okay, I have a question. So the right answer, we will have to put the dots, me telling you that it could continue
Yeah.
after the 7, and the dots before the 2 telling you that it could go lower than that.
Yeah,
Is
sure.
that how you want to see the answer, or?
No, for this case, I just want to see if you have at least one element, then it's not empty. By definition of empty set, you have one
Okay.
element, it's not empty. So here's one element, here's an element, that's it.
Okay.
That's all you have to show. Let's look at number 2. Let's look at number 2. X is a number less than 3 and greater than 5. I want you to find one number, just one number, that is satisfying both condition, common condition, which is a number that is less than 3 at the same time, greater than 5. Is there a number existed? Is there a number less than 3 at the same time, greater than 5? Is there a number existed? Can you find a number which is less than 3 and greater than 5? Truly less than 3 and greater than 5. Is there such?
Would this be an empty set because there's none?
There is no such number less than 3 at the same time greater than 5. So no elements, right? Here. So yes, this is empty set. Do you see the difference? Okay, do we see the difference of these two? Okay, so empty set means no elements. Okay, empty set means no elements. All right, so the next one we have studied ellipsis. We already did ellipsis. I want to go over the ellipsis. So the bottom of the page, second half of page 76. Okay, 3 dots. 3 dots, okay, 3 dots right here. 3 dots after the element D is called ellipsis. All right, so we want to write it out, the letters of alphabet letters of English. Okay, right here. L is set of A, B, C, D, E, F, G, blah, 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 all the way up to Z. There are 26 of this. I mean, we can write it out, but that's a lot of work. So I write capital L as the letter, a set of A, B, C, D, and then I get tired. I put 3 dots right here. I put 3 dots. And I know the last element is a Z. So I put a Z there and close the set. Meaning ellipsis is applied here, ellipsis here. Okay, elements in the continuing pattern, okay, and including this. So I know R is here. I know P is here. You know what I mean? It's not showing in your eyes, but it's skipped in here, but it's there. Okay, so hiding in somewhere out there. All right, so are we okay with this idea of ellipsis? Let's try problem 47. Okay, let's try problem 47. Okay, you see this notation? This is the first time you see the notation right here. First time you see the notation, this. Okay, let me make it big. Can you see it? Okay, let's see. Okay, do you see the notation here? Okay. This means, do you see this notation? What is that notation? That means set of natural numbers. So this is a set of natural numbers. Okay, you see that? That's natural numbers. And there is another notation, this notation. Okay, so we have an open like mouth like this, and then bar inside like that. Okay, bar inside like this. This is the typical notation for set, and we have to understand, we read this as is an element of. That's how you read. Okay, is an element of. Okay, notation is an element of. That's the next page, and we want to go over this. So since already have this notation, we read this as X is an element of natural numbers. X is an element of natural numbers, meaning I do not care about decimal place. I do not care about the fraction. I only look at the natural numbers. X is an element of natural numbers. Is an element of, okay? Is an element of, okay? So open mouth to the right and then put the bar inside. Is an element of, okay? Notation. What if it's not? Backslash. In math, anything with a backslash, not. Equal, not. You know what I mean? Less than, not. So anytime you have the backslash means not, okay? So element of, not. Get it? Okay. All right, so go back to problem 47. Go back to problem 47. Let's read this. X is an element of the natural numbers where X is, okay, between 6 and 137, less than equal to, and strictly less than. You see that? So less than equal to, we include the 6. Strictly less than, up to the point, but less than that number. So the set is 6, 7, 8, 9, 10. I get tired. Ellipsis. And what's my last number? 136. It's because the number less than 137, natural number is 136. Okay, so there are like over 100 numbers. I put dots. All right, question. Okay, so let's look at this notation, next page. Okay, let's get the notation. All right, go back to the notation here, make it bigger. And you see an element of, okay? A is an element of S. A is not an element of S, okay? Let me write it big. A is an element of S. A is not an element of S. Do you understand this notation? All right, so let's have a couple of examples before we do problem 48. Suppose I have a set A, B, C. I have a set A, B, C. Is A an element of the set? Another way to say, you look at the box with the element ABC, the members of the set are ABC. Is A one of these guys? Yes. So yes, this is true. Let me give you another example. So instead, I want to say, is F an element of set ABC? Can you see F? No. So F is not an element. Do you understand this? Let me give you another example. Okay, so here is A is an element. Okay, it's because A is here. How about say set A? Is set A an element of set ABC? Okay, now you can think as here's a box. Remember, the set is a box. Here's A, B, and C sits in here. Now here's a small box with the set A. Is A an element here? Meaning, can you find the box of A in here? You have A, you don't have a box A. You know what I mean? You can think as a set A. All right, set is a box. So if you have A in the box, I understand A in the box, but you don't have a set A in the box. So this is not an element. A is an element, but say is not an element. Okay, let me give you another example. You ready? Set A of the set. Okay, so look at the element. Okay, look at the element. So what are the elements of the set? We have two elements. Remember, we have two elements. One element, another element. Are you okay with this? One element and another element. So my question is A an element? Yes. Why? Because this A is this A. So yes, it's an element. Are we okay with this? Now I want to ask you, is set A an element? Yes, it's because set A is set A. I want to make it exact same match. So yes, both are elements. Okay. Let me give you another example. Suppose I have 1, 2, 3, ... 100. So this is a set. This is a set. I have 76. Is 76 an element? Is a 76 inside of the set? Yeah, sure. It's ... right here, ... but it's in here, right? It's in here. Skipped it. And let me give you another example. Is root 2 an element? Is root 2 part of 1, 2, 3, 4, 5, 6? Can you find root 2? Root 2 is an irrational number. No, it's not. Do you understand this notation? Okay, let me give you one more and I let you play. Here's one more. So I have set A, B, C, ... Z. Okay, ABC ... Z. Is W an element? Is a W an element? Is W inside of the set? Yeah, it's there, right? Let me give you another example. So instead of W, if I say alpha, is alpha the part of the elements? No, alpha is not English alphabet. So no, it's not an element. Are we okay with this notation? An element of, not an element of, how to verify? Okay, so here's your turn. I want you to try problem 48. So there are 3 statements verified. Which one is true? Which one is not? Why not? Okay. Okay, so let's do it together. So part one. R is an element of set A, B, C, D, Z. Okay, Z. All right, let's begin with Aaron. Is this true statement, Aaron?
Sorry, we're talking about the first one.
Right here. Okay, is this true?
Yes,
Why?
because it lists like the alphabet with like the ellipsis, and then it ends at Z, and R is between there.
Right, R is somewhere out here, so it's a true. Very good. Let's move to number 2. Okay, Olivia, what do you think?
I said true because
True.
7 is not an element.
Okay, 7 is not in here. It's not an element. Very good. Let's move to number 3. Egan?
I honestly didn't understand this one.
Okay, you have a set AB. So Egan, what are the elements of set AB?
A and B.
A and B. Okay, now this, we read this as a set A. Okay, is a set A element of set AB.
Oh yeah.
So elements are AB, set A. Is a set A it's the same as one of these?
Yes.
No,
No.
here's
'cause-
A, here's a set A. Are they same?
No.
No, so what do we say then?
False.
False. Okay, so don't forget this. Okay, so A and set A. All right. All right, the next one is the set of natural numbers in the counting numbers. So I want to pull it up here. So we all learned meaning of natural numbers and counting numbers. Okay, that's bottom half of page 77. All right, so this is the set of natural numbers or counting numbers. And I want you to practice this, okay, for problem 49. So there are 3 parts. Express this into roster method. So we did roster method a few minutes ago. I want you to understand the meaning of natural numbers. So go ahead and try this and let's do it together. Okay, a few minutes. All right, so set B is a set of natural numbers. Okay, so I also said natural numbers is just a number. So set of numbers greater than or equal to 25. Okay, greater than or equal to 25. All right. Kayla, set B is what? Kayla, you're in mute. I can't hear you. I think you say something, but I can't hear you.
Sorry. Yeah, no, so I put A equals parentheses or bracket 25, comma 26, comma dot with another parentheses. That's what I put.
It goes forever. Very good. Okay, that's what it is. Okay, I usually write it 3 or 4 elements before I put dot so I can see the pattern. Very good, Kayla. Any question? Well, good. Okay, let's move to number 2. E is a set of, okay? E is a set of, let's see, Leslie?
I put E is a set of 2.
Is it 2 only? Numbers. Even numbers. More
So it could be 2, 4, 6, dot.
Those are even numbers. Yes, it's more than just one number. Okay, it's more than one number. So dot. All right, let's move to number 3, set F. Caitlin, do you think you can do it or are you still confused? Okay, Jason?
I did 7, 8, and 9.
7, 8, and 9. Okay, it's because between means exclude the endpoint. So we exclude the 6 and 10, and in number between 6 and 10, those are 7, 8, and 9. Are we okay with the set of natural numbers? Are we also okay with the ellipsis? Okay, very good. Let's move to the next page. Okay, that's on page 78. Okay, as you see, for each page, top of the page, we have a box. Okay, I make it bigger on the screen here. So each page, the top of the page has a box and then examples or problems. And then next page, and then there's a box and then examples and problems and things like that. So we are on page 78, Wyatt. So you just joined us. So page 78, 79, as you see, all these pages, whether you have one box or two boxes, it's because all those are the definitions. There are so many of those definition bars, okay? And then we have example following. So next thing is, we want to know the cardinal numbers, okay? So first we have to understand the meaning of cardinal numbers. Cardinal number means we are looking at the number of elements, okay? How many are they? Number of elements. So for example, you look at part 3 here, there are 3 elements, 7, 8, 9. You know what I mean? So cardinal number is a 3 and so on. So let's have the example, go back to here. So the cardinal number is the number of elements of a given set. Number of elements of a given set. We write it, number of elements of a set A, write it out this way. Some people called A with the absolute value, same thing, cardinal number. You know what I mean? Some with the absolute value. Now here's a set. I want to show you. If I have a set A, okay, if I have a set A, here's the symbol. I have set A as 1, 2, 3, 4, 5. Let me give you an example. And my question is, can you find the cardinal number? So cardinal number of A means how many elements in the set? So 5. You understand this? I usually denote with the letter N of A, number of elements of set A or cardinal number. Okay, so that's the name, cardinal number. That's the name, cardinal number. Let me give you another example. I have a set B, this time 1, 1, 3, 2, 2, 2. Okay. I want to find how many elements in set B. Do you understand what I'm doing in here? I want to find how many elements in set B. All right, so the first question that Italy was asking, does matter orders, okay? So can we put all the orders? So 1, 2, 3 and order matters? The answer is no, order does not matter. So you can write it like this. Number 2, do we allow the duplicates? Meaning I have 2 1s, I have 3 2s, right? So duplicate do not allowed. We don't count twice. So even though there are 2 1s, I only count once. 3 2s, I only count once, meaning I only have 3 elements. Okay, 3 elements. So that's what we call distinct elements. We do not count double, triple, and things like that. We only count once. Are we okay with this? Let me give you another example. All right. Any question of a cardinal number? Not okay, so it's good. If I said A equal to like this, what's the cardinal number of set A? How many elements in the set? This is empty set. Empty set has no element. No element. It's a 0. You understand this? Let me give you another set, set B, which is a set of empty set. How many elements of set B has? Set B has empty set inside. So empty set is sitting inside of the set. So 1. Empty set is an element of the set. Remember, we have a box. In the inside of the box, we have an empty box here. So that empty box is an element. You know what I mean? All right. Let me give you another example. Okay, what's the cardinal number of a C? How many elements in the set?
99.
99. There are 99 elements in the set. Agree? 99 elements in the set. Let me give you another example. What's the cardinal number of L?
26.
26 letters, right? Let me give you one more. Sorry, I keep having this. Okay. E. Cardinal number of E. How many elements of set E? Forever, right?
Infinite, yeah.
And so infinite is the notation of the ribbon, infinite. Okay, infinite. Oops, where is it? Infinite, okay, infinite. I want to go to, oops. Make it big, infinite here. All right, so as you see, the sets like this with the cardinal number is a finite number like this. So this type of set, if you are able to find the finite number, it's called a finite set. If the cardinal number is infinitive like this, it's called an infinite set. Okay. Do you understand how we separated finite set and infinite set? So as long as the cardinal number is a finite, we said finite set. Infinite many, infinite set. Do we understand this? Infinite many with infinite set. Now, here's one question. Okay. Do you remember very beginning, okay, the first page of a set theory, we said set is clearly determined, remember that? And if you find the elements are clearly determined, we said the set is well-defined. Now, is an infinite set well-defined?
I don't think so, because there's no specific number that could go on forever.
You can go forever, but we know what numbers are here. Do you understand this? So we know 10 is here. We know 100 is here. We know 101 is not there. You know what I mean? It's clearly determined. Is this number clearly determined? What are those numbers? Yes, so it is well-defined, okay? So in fact, MA 105, all are well-defined. We don't care about if it's not well-defined, okay? So elements are clearly determined. So even if it's infinite many of this, clearly determined. Another way to say, we know what are the elements in here, okay? We know 100 is here. We know negative 25 is not there. You know what I mean? So it's a clearly determined, the elements are here. All right, so I don't know why this page is keep big. I want you to try problem 50. Okay, problem 50. Go ahead and try problem 50. Why I only have a 2? There are 4 parts. Okay, so problem 50. It has 4 parts. Find the cardinal number. Okay, find the cardinal number of these 4. Okay. Can you see? Okay, good. Cardinal number. All right, let's do, what's the cardinal number of set A? Connor, what's the cardinal number? 4? Oh, Leslie, you answered that. Okay, that's fine. Connor, you do part B. Okay, what's the cardinal number of set B? How many elements in set B?
I didn't get this one.
Okay, you're looking at the number of elements. Okay, look at set B. What are the elements of set B?
0.
0. So how many are they?
So 0 then? Or what?
It's 1 because 1 element. 0 is the element, right? So cardinal number is 1. All right, let's look at number 3. Cardinal number. How many elements in cardinal number? Okay, for C, MC. Aaron? How many are they?
I said 10.
Is it 10? Let's see. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Isn't 11? Let's count it. Okay. Let's try. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay. 11. Okay. So you get an idea. I just counted wrong. That's fine. What's the current number of a D? What's the current number of empty set? Olivia?
I said 0.
Very good. Yes, that's how it works. All right. So the next thing is, I want to play a little bit. Okay. So we understand the current number. Are we? Okay. We all good. So here is set A. I have set A, B, C. Okay. Here's the set B. I have a B, C, C, A. Okay. And I also have a set C. It has A, D, E. All right. Are we okay with this? Now I want to find the current number of A. What's the current number of A?
3.
3. What's the current number of B?
3.
3. What's the current number of C?
3.
3. Okay, are we okay with this current number, Egan? So you can answer all this. Now I want to find the elements of A, B, and C. So what are the elements of A? Elements of A are A, B, and C. Agree?
Yes.
Elements of a B are A, B, and C. Agree? Okay, remember, order does not matter, no repetition. Elements of C are A, D, and E. Okay, so we have a couple of things to be sure on this. Okay, so as you see, elements of A and B are same. Agree? Even though they write it in different ways, A and B, set A and set B has the same element. Agree? Same element. So same element. A and B has the same element. If two sets have same element, I want to say they are equal. Equal sets. Okay, equal sets. So I write it A, can you see it? You can see it. A is equal to B, notation for equal. Are we okay with this notation? Equal set. All right. Now I want you to look at set B and C. It's not same element, right? It's not same element, but look at the current number. It has the same number of elements. You know what I mean? It's not same element. The numbers are same. Current numbers are same. We called equivalent sets. We called equivalent sets. Equivalent, 3 bars. B is equivalent to C, 3 bars. Equal sets, it has the same elements. Equivalent sets, same number of elements. Do you understand this? Equal set means same elements. Equivalent set, same number of elements. Okay. Do you understand this? Let me give you one more example before we exercise. Okay, suppose I have set AB. I have set CD. All right. Are they equal set or equivalent set?
Equivalent.
Equivalent, same number of elements, equivalent. Okay, if I have a set A, I have set A, are they equal set or equivalent set? Equal set and equivalent set, right? It's only one element, A. Both. Okay. Here's a tricky question. Here's a tricky question. You ready? Empty set, empty set. Equal set, equivalent set. They're equal, right? Empty set is empty set. Empty set is equivalent set. Okay. Do you understand this? Empty set, both. All right. Here's one other thing. One more. Set A. Set A, empty set. Equal. No? Yes?
It would just be equal, right? Not equivalent.
Why it's equal, Egan?
They have the same element in them.
Equal set means it has the same element. So set A has element A, set A empty set element and A and empty. Do they have the same element?
Oh, no, because
No, so that's not equal. Okay, my next question. Are they equivalent sets? Okay, what's the cardinal number?
oh, 1.
1. What's cardinal number? 2. They're not equivalent. Okay, so number of elements. All right, so I want you to turn the next page right here. So equal set, empty set, and excuse me, not empty set, equivalent sets. Okay, equal means elements are same. Equivalent means number of elements. Go ahead and try 51. Let's practice this. And we move to the next one. Equal set, equivalent set. Okay, equal set, you compare the elements. Equivalent set, you compare the cardinal number. Okay, let's do part 1. Okay, so it says, look at the notation. Set OLD is equal to set DOL. So equal means, okay, it has the same elements. Okay, so set and set. Look at the element. Are they same element? Dorothy, is this true statement or not?
It's true, they're equal.
Very good. It's a true. Order does not matter. Excellent. Okay, let's look at number 2. We have set 4, 5, which is equal to set 5, 4, and empty set. Remember, equal means same element. Okay, equal means the same element. All right, set 4, 5 is equal to set 5, 4, and the empty set. Look at the elements of the set. Okay, look at the elements of the set. Michael, true or not?
The second one is not true,
Not true. Why not?
because it has 2 and 3 things in the set, so it's not equal.
This is not in the set, right? Remember, we have to have a same element. So element in one set is a 4, 5. Element of another set is a 5, 4, and empty set. Okay, so we have extra empty box inside of this set. So false. Very good. let's look at number 3. So notation of this is the same as equivalent notation, okay? That or that, okay, notation right here. Notation. Set MOM is equivalent to say MO. Look at the Cartan number. Now this time you look at the Cartan number. Look at the Cartan number. Set MOM equivalent to MO. Cartan number. Look at the Cartan number. Look at the Cartan number. Wyatt.
I said this was false, but I
Okay.
think it might be true.
Huh?
I said it was false, but I'm not totally sure. I'm a little bit confused after going through the answers for 1 and 2. I think I might have flipped them. with
Okay.
part- Yeah,
So in order to check the equivalency here, we have to check number of elements. What's the Cartan number of MOM? How many elements are MOM?
2,
2. How many elements are there in MO?
2. So it's
2.
true.
True. So 2 elements equal to 2 elements. So it's true.
Okay.
You are looking at the Cartan number. Okay, you're looking at the Cartan number. All right, here's another one. Set and set, are they equivalent? Aaron? Your name is here.
I'm kind of like confused about this one.
Okay. What makes confused?
Because like the overall like value of both of them is the same, but it's like I don't know, like the names are different. So like I don't know if that would be true or false.
Equivalent.
Oh, so yeah, it'd be true.
Okay, so here is a highlighted word. Okay, here is a highlighted word. Equal, same elements. Equivalent, same number of elements. Do you see the difference? So that's 2 different things. I'm not asking same elements. I'm looking same number of elements. So Aaron is here. So there are 2 elements in here. There are 2 elements here. I don't care what elements are they. They are having same Cartan numbers. So it's true. Do you understand this? So equivalency, we are looking at number of elements. We are not looking at the element itself. If you're looking at the element, then equal set. If you're looking at the number of elements, that's equivalent set. Do you see the difference? All right, so 52, 53, I leave you as exercise for next 2 days. Instead, I want to move to universal set. I want to finish the chapter section today. Okay, we'll see how far I can do. Next one is called the universal set. Universal set denoted as, okay, capital U. Okay, universal set denoted as capital U. I don't know why this is not moving. Capital U, okay, right here, U denoted set. And that U contains all the elements in the problem, okay? All the elements in the problem. So let's have an example. What does that mean, universal set? Okay, describe universal set of indicated all the elements set. So I have set A, I have set B. Universal set contains everybody in set A and B. So I want to write it out, all these guys, okay? Everybody in set A and B. That's what we call the universal set. So what's universal set? Okay, so what's universal set? Egan, what's universal set then?
I don't know, honestly.
Okay, so here is a set A, and an element. Here is a set B, have an element. The universal set lists everybody. Okay, all elements of a given set.
So all of them together?
All of them. So we write it, Jeopardy. Okay, The Voice, Amazing Race, Survivor, Hell's Kitchen, Wall of Fortune, Dance with Stars, and Cups.
Oh, okay.
That's what the universal set is. Do we understand idea of a universal set?